In this video, we are going to discuss the hydrolysis of the family of esters. The word hydrolysis means to break a bond in acidic conditions, in basic conditions, or by an enzyme. The products formed upon hydrolysis will have less carbons than the original organic compound. Let's examine the hydrolysis of an ester. The bonds in red will be broken, and we are going to exchange the methoxy group for the hydroxyl group. The acid in acidic hydrolysis is a catalyst. It is not used up in the reaction, and only small amounts are needed relative to the amount of the ester. Because this reaction is reversible, a large amount of water and small amount of the acid is used to drive the reaction to the right, that is, to cleave the bond between the carbonyl and the oxygen. In this case, the hydroxyl group coming from water will be added to the carbonyl, and the hydrogen will be added to the alcohol part. The result will be the formation of the original carboxylic acid used to synthesize the ester and the alcohol. We can say that the acidic hydrolysis of an ester is the reverse of the acid-catalyzed ester formation from a carboxylic acid and an alcohol. Now let's explore the hydrolysis in basic conditions. The reactant is going to be the same. We have a molecule of water that is going to split an ester in two parts, but now we are using basic conditions. We will add the OH to the carbonyl and the hydrogen to the alcohol part. Now let's exchange the methoxy group with the hydroxyl group, and we produce a carboxylic acid and an alcohol. However, if we explore our products, now we have an acid, a base, and an alcohol. Since we know the nature of carboxylic acids is to react with bases, this will not be an end product. The carboxylic acid will continue reacting with the base that was used as a catalyst. We can actually add partial negative charge to this oxygen, and a partial positive charge is the acidic proton. We can also assign a plus charge to the sodium and a negative charge to the hydroxyl group because this is the base. Upon reaction of the carboxylic acid with the sodium hydroxide, our products are 1 molecule of water and the sodium carboxylate. Basic hydrolysis, different than acidic hydrolysis, is not an equilibrium reaction. The formation of the carboxylate salt drives the equilibrium to the right, making the reaction irreversible. Basic hydrolysis is often preferred. In this hydrolysis, the base is a reactant and is needed in equimolar amounts relative to the amount of ester, and it is consumed in the reaction. The hydrolysis and the formation of esters in living organisms takes place continuously. Triacylglycerols and many other lipids in our bodies and in our diets are esters. Digestion of these compounds is a very simple matter of ester hydrolysis. Triglycerides contain 3 ester bonds, and the difference is that in living organisms, instead of using strong acids or strong bases like sodium hydroxide or hydrochloric acid, our bodies will use enzymes. Very soon in the chemistry lab you will be synthesizing soap, and that is nothing but a basic hydrolysis of a triester. Lipids with very long hydrocarbon chain are hydrophobic substances because of all of this high content of carbons. In the chemistry lab you are going to be boiling a small amount of cooking oil with sodium hydroxide to hydrolyze 3 ester bonds. The product of this hydrolysis of the triglyceride, it will be 1 molecule of glycerol, which is a triol, and 3 units of fatty acid associated to the sodium. These substances are hydrophobic in one side and hydrophilic in another side. In the biochemistry part, we are going to call the long hydrocarbon chain to be a tail and the hydrophilic part to be a head.